Hello, in this lecture we will find the area of the yellow circle. In the picture you can see semicircle, and inside the semicircle we have yellow circle. The touching point between the semicircle and the yellow circle is at point P, and the center of the semicircle is at point O. And also we know that the line segment PQ equals to 7 times root 2. And we want to find the value, we want to find the area of the yellow circle. Again, the center of the semicircle is at point O, and let's assume that the center of the yellow circle is at point M. And we will connect together points M and O by a straight line. Actually, MO is the radius of the yellow circle, because it starts, the line segment MO starts from the center of the yellow circle, that is to say from point M, and ends at point O, that is a point on the yellow circle itself. For that reason, MO is defined as the radius of the yellow circle. We will call it small r. And we actually have a rule. I will call it rule number 1. Rule number 1 states that if two circles touch each other, either internally or externally, then their point of contact lies on the straight line joining their centers. So I will read again rule number 1. According to rule number 1, if two circles touch each other either internally or externally, then their point of contact lies on the straight line joining their centers. Okay, now I will explain the meaning of the rule. If two circles touch each other, in our case, the yellow circle touch the semicircle at point P, then their point of contact, that is to say point P, lies on the straight line joining their centers. So the rule number 1 states that the point of contact, that is to say point P, lies on straight line. And on which straight line it lies? It lies on the straight line that joins their centers together. That is to say, MO. MOs. That is to say, PMO is a straight line. Okay, again I will explain. If two circles touch each other either internally or externally, as I've already said, those two circles, the yellow circle touches the semicircle at point P, then their point of contact, that is to say point P, lies on the straight line joining their centers. So rule number 1 states that their point of contact, that is to say point P, lies on the same straight line that joins the centers together. That is to say, it lies on the same straight line as M and O. So if MO is line segment, then point P lies on the same straight line. That is to say, PMO is the straight line, because the line segment that joins the centers together is MO. And the rule number 1 states that point P lies on the same straight line. That is to say, PMO is a straight line, or we can also say that PO is a straight line, according to rule number 1, because rule number 1 states that the point of contact, that is to say point P, lies on the straight line. So point P is part of a straight line. Which straight line? The straight line that joins their centers together. That is to say, line segment MO is a straight line, and point P lies on the same straight line. That is to say, PMO is also a straight line. Or we can also say that PO is a straight line. Okay? So I will connect together points M and P. Actually, the line segment MP is also the radius of the yellow circle, because it starts from the center of the yellow circle, that is to say point M, and ends at point P, that is a point on the yellow circle itself. For that reason, MP is defined as a radius of the yellow circle, and OP is a straight line. So again, I will read again the sentence. If two circles touch each other either internally or externally, then their point of contact lies on the straight line joining their centers. So those two circles, the yellow circle and the semicircle, touch each other at point P, and the point P, the point of contact, lies on a straight line that joins the centers together, and the centers of the circles are point M, that is the center of the yellow circle, and the center of the semicircle is point O. So the line segment that joins their centers together is MO, and point P lies on the same straight line. That is to say, PMO is a straight line, or also we can say that PO is a straight line. Okay, so actually we can conclude that PMO or PO is a straight line, PMO is a straight line, or PO is a straight line, and we also can say that PO equals to 2 times small r. PO equals to 2 times small r. Okay, PMO is a straight line, or PO is a straight line, and PO equals to 2 times r, and 2 times r is defined as the diameter of the yellow circle. Okay, so PO is actually the diameter of the yellow circle. Okay, PO is the diameter of the yellow circle because it equals to 2 times r. Okay, generally the diameter is defined as 2 times the radius of any circle. So PO equals to the diameter of the yellow circle. And because of the fact that PO is a straight line, we can also say that PO is the radius of the semicircle. Okay, PO, I will write it down. PO equals to the radius of the semicircle. Why? Because PO starts from the center of the semicircle and ends at point P, that is a point on the semicircle itself, and that is exactly the definition of a radius. Any line segment that starts from the center of any circle and ends at a point on the circle, it is defined as the radius of that circle. For that reason, PO or OP is the radius of the semicircle, and I will call it capital R. So PO is the radius of the semicircle, and it is defined as capital R, while small r is the radius of the yellow circle. Okay. So actually PO equals to 2 times R. PO equals to the diameter of the semicircle and equals to 2 times the radius of the semicircle, but PO also equals to the radius of the semicircle. It equals to R. Okay, from one side PO equals to 2 times R, small r, the radius of the 2 times the radius of the yellow circle, and from the other side PO is the radius of the semicircle, that is to say PO equals to capital R. So from that two equations we can deduce that R equals to capital R equals to 2 times small r. Okay, that will be our first equation. Capital R equals to 2 times small r. Okay, capital R equals to 2 times small r. So PO is the radius of the semicircle, and for the same reason we can say that OQ is also the radius of the semicircle, because line segment OQ starts from point O, that is the center of the semicircle, and ends at point Q, that is a point on the semicircle itself. And that is exactly the definition of radius of any circle. Any line segment that starts from the center of the circle and ends at any point on the circle itself is defined as the radius of that circle. And for that reason, because of the fact that point O starts from the center of the semicircle and ends at point Q, that is a point on the semicircle itself, it is defined as the radius of the semicircle, and I marked it as capital R. So we have here two radiuses of the semicircle. OP is the radius of the semicircle, and also OQ is the radius of the semicircle. We have another rule. I will call it rule number 2. According to rule number 2, in any circle, a radius and the tangent to that radius are perpendicular to each other. read again rule number 2. Rule number 2 states that in any circle, a radius and the tangent to that radius are perpendicular to each other. So if we have radius let's call it r, and we have tangent to that radius, let's call it t, then the radius is perpendicular to the tangent. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay, so in any circle, a radius and the tangent to that radius are perpendicular to each other. So we actually can implement rule number 2 in our circles, because actually MO is the radius of the yellow circle, and QO is the tangent to that radius. For that reason, angle POQ equals to 90 degrees, and also angle POL equals to 90 degrees. Okay, so we actually have a right triangle. POQ is a right triangle because angle POQ equals to 90 degrees. And we know that side OP of the right triangle equals to capital R, and also side OQ of the right triangle, OPQ, equals to also to capital R, and the hypotenuse of the right triangle is 7 equals to 7 times root 2. Okay, now I will draw again the right triangle POQ. So this is the right triangle POQ. As you can see from the drawing, side PO of the right triangle POQ equals to R, and also side OQ of this right triangle equals to R, capital R. OP also equals to capital R, and the hypotenuse of this right triangle OPQ equals to 7 times root 2. We actually can implement the Pythagorean theorem in order to find out the value of capital R. And actually the Pythagorean theorem states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So I will read again the Pythagorean theorem. So the Pythagorean theorem states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, I will explain the theorem. Actually, it applies only to right triangles, I will add. It applies only to right triangles. Actually, if we have right triangle is a triangle that one of its angles equals to 90 degrees. Let's say this angle is 90 degrees. The square of the hypotenuse, that is to say AB square, equals to the sum of the squares of the perpendiculars. That is to say equals to BC square plus AC square. Okay, the square of the hypotenuse, that is to say AB square, equals to the sum of the squares of the perpendiculars. That is to say AB square equals to BC square plus AC square. Okay, so in our right triangle, we will implement the Pythagorean theorem, and we will get that, I will call it equation number 2, PQ square equals to PO square plus OQ square. Okay, PQ square, the square of the hypotenuse, equals to the sum of the squares of the perpendiculars. This is to say PQ square equals to PO square plus OQ square. Okay? But we know that PQ equals to 7 times root 2, PO equals to R, and OQ equals to R, so we can put the data in the equation number 2, and we will get that 7 times root 2 square equals to R square plus R square okay, 7 times root 2 equals to 49 times 2 equals R square plus R square equals to 2 times R square. So we got that 49 times 2 equals to 2 times R square. I hope that you understood what I did here. I will repeat again. 7 times root 2 square equals to 49 times 2, because it is 7 root equals 7 square equals to 49, and root 2 square equals to 2, and R square plus R square equals to 2 times R square. I will divide the equation by 2. We will get that 49 equals to R square. Now we take a root out the equation number 2. We'll get that R square root is R, and the root of 49 equals to plus 7 units, because even though that the root of 49 is 7 and also minus negative 7, but because in our case the negative answer is not true, because we are talking about radius, and radius must be a positive number, so we'll take into account only the positive answer. So we got that the value of the radius of the semicircle, R, capital R, equals to 7 units. Okay, the value of the radius is 7 units, but according to equation number 1, capital R equals to 2 times small r. Okay, so I write it down. according to equation number 1, capital R equals to 2 times small r, and we found out that capital R also equals to 7, so we can substitute R by 7 in the third equation. We'll get that seven equals to 2 times R. So we substituted R by 7 because R equals to 7. We got that 7 equals to 2 times R. We will divide the equation by 2. We'll get that small r equals to 3.5 units. So we divided the equation by 2, and we got that small r equals to 3.5 units. Now that we know the radius of the semicircle, it is very simple to calculate the area, because the area of any circle, I mark it as equation number 3. The area of the formula for the area of any circle is A, abbreviation for area, equals to pi times r square. So this is the formula for the area of a circle. A equals to pi times the radius square. But we know that the value of r is 3.5 units, so we can substitute r in the third equation by 3.5 units. We'll get that so we substituted r by 3.5 units. We got that a equals to pi times 3.5 units square. The 3.5 units square equals to 12.25 multiplied by pi equals to the area of the yellow circle, and pi times 12.25 equals to, so that is our final answer to the question. The area of the yellow circle equals to 48.38 units. Okay, pi times 12.25 equals to 38.48 units. That is the area of the yellow circle. Now I will summarize the lecture. We actually wanted to find the value of the yellow circle Okay, we wanted to find the value or the area of the yellow circle. And actually the formula of the area of any circle equals to pi times r squared, so the only thing that we have to know is the radius of the yellow circle, and then we will find the area, because the area equals to pi times r squared. So we squared the radius, we multiply it by pi, and in this way we get the area of the yellow circle. Okay, but in the picture we have a semicircle, and inside the semicircle we have yellow circle. Actually the center of the semicircle is at point O, and the touching point between the semicircle and the yellow circle is at point P. And also we know that PQ, the line segment PQ, equals to 7 times root 2. We actually connected points M and O together, and that is the radius of the yellow circle. And according to rule number 1, if two circles touch each other internally or externally, then their point of contact lies on the straight line joining their centers. I will explain again the meaning of rule number 1. The yellow circle touches the semicircle at point P. So according to rule number 1, it is the point of contact, and this point of contact, point P, lies on the straight line joining their centers. So if we connect together the centers of those circles, that is to say, if we create the line segment MO, then point P must be on the right line of the PMO. Actually, point P must be on the same right on the same straight line that MO is in. Or PMO creates a straight line, or the point of contact, that is to say point P, lies on the straight line joining their centers. So the line segment that joins the two centers together is MO, and point P is on the same straight line. That is to say, PMO is a straight line, or we can say that PO is a straight line. Okay, so and then we connected points M and P together. MP is also the radius of the yellow circle, because it exits from the center of the semicircle and ends at point P, that is a point on the yellow circle. For that reason, MP is the radius of the semicircle. And also we can say that OP equals to 2R, that is to say, OP is the diameter of the semicircle, and because of the fact that OP is a straight line, we can say that OP is actually the radius of the semicircle, because it OP starts from point O, the center of the semicircle, and ends at point P, that is a point on the semicircle itself. For that reason, OP is defined as the radius of the semicircle, because the definition of a radius is line segment that starts from the center of the circle and ends at any point on the circle itself. And that is exactly OP. It starts from the center of the semicircle and ends at point P, that is a point on the semicircle itself. For that reason, OP is the radius of the semicircle. I called it capital R, while MO is the radius of the yellow circle. OP is the radius of the semicircle, and for the same reason, OQ is also the radius of the semicircle, because it starts from the center of the semicircle and ends at point P, at point Q, that is a point on the semicircle itself. For that reason, OQ is the radius of the semicircle. So we have two radiuses of the semicircle, OP and OQ. But we have also rule number 2 that states that in any circle, a radius and the tangent to that radius are perpendicular to each other. So if we have a radius, we call it R, and the tangent to that radius, we call it T, the radius will be perpendicular to the tangent. That is to say, this angle is 90 degrees and also this angle is 90 degrees. And we actually can implement this rule in our circles, because MO is the radius of the yellow circle and QO is the tangent to that radius. For that reason, this angle is 90 degrees and also this angle is 90 degrees. So angle POQ is 90 degrees and also angle POL is 90 degrees. So actually we got that POQ is a right triangle because of the fact that angle POQ equals to 90 degrees. So I do again the right triangle POQ, and I implemented the Pythagorean theorem in order to find out the radius of the semicircle, and according to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, and it is only applied to right triangles. So the square of the hypotenuse, that is to say AB square, equals to AC square plus BC square. Okay, so in our specific right triangle, we can say that 7 times root 2 square equals to R square plus R square. Here, and we got the capital R equals to 7 units, but according to the first equation, we know that capital R equals to 2 times small r. So we have from one side R that equals to 7 units, and from the other side we know that R equals to 2 times R. So from one side r equals to 7 units, and for question 1 you know that capital R equals to 2 times small r, so we can substitute capital R by 7. We get that 7 equals to 2 times r. We divided the equation by 2 and we got to the answer that capital R equals to 3.5 units. After we know the radius of the yellow circle, it is very simple to find out the area, because the area equals to pi times r square. We can substitute r by 3.5 units because r equals to 3.5 units, so we substituted r by 3.5 units. We got that a equals to pi times 12.25, because 3.5 square equals to 12.25, and the area is pi times 12.25. The area of the yellow circle equals to 38.48 units. Okay, so the area of this yellow circle equals to 38.48 units. Okay, thank you very much.